Talk about quality in terms of control and assurances thereof. So let us understand the phases of qualities. What are they? They are the inspection before the production, inspection after the production, inspection during the production. So what are we looking into it before and after the production? Corrective actions which needs to be taken during productions and the quality that has been built into it. So as we grow from left hand side to the right hand side, the least progressive and the most progressive. So the more you inspect, the better it is, the more concerned are you for quality perhaps. So what are we doing about it? Is the acceptance sampling. It is the process control and all about continuous improvement. So inspection, how much should we do it? How often should we do it? Where should it be done? When should it be done? Should it be done on site? Should it be centralized? This is what we are looking as far as acceptance and sampling, process control, and the acceptance sampling is call about it. What are we looking? The inputs. What are we looking over acceptance sampling? The outputs. What about the process control? Is the transformation process that we undertake around here. We need to pick everything in as far as the raw materials are concerned, as far as the finished products are concerned, also as far as work in progress production are concerned. We need to check quality at every stages. So inspection cost, how much or how often? Now remember, the optimal amount of inspection is where the cost is least, and that is what we are looking into it. If we uh, plot cost on the on your y-axis and number of inspection on your x-axis. If you look into it, see the number of inspection. This is the line which says the cost of the inspection. The more the number of inspection, the more the cost of inspection would be. So if you have no inspection, the quality might be differing, right? So cost of passing defectives. The more stringent the inspection, the less chances that defective products will be passed around. At this junction is where the crossing is all about it. Remember, this plus this is the total cost. The cost of inspection and the cost of defects will mean your total cost, right? So at this junction, will your total cost and it is the optimal amount. So you need to find out how many or how frequently inspection needs to be done. With increase in inspection activities, remember the cost of undetected defects. So we have understood the raw material and purchase cost, never to inspect poor quality of raw materials, finished products. Poor products returned by customer can also lead to additional shipping cost. Before a costly operation, never, I repeat, never waste resources as men, material, and machines. Before an irreversible process, let's say pottery, ceramic, tiles. What is irreversible process? Because you cannot go back to the original. You have to break it and probably you have to discard it. But you cannot rectify it. So tiles, PC chips, glass filaments, before before a covering process like painting, like plating, something which is done for once and for final, where to expect. These are the points that need to be kept in mind. Centralization versus on-site inspection. Inspection of ships, nuclear power plant, petroleum refinery, chemical plants, equipment for cracks, brittle fracture, example, both external and internal inspection. Lab tests include blood test and material test. We talk about SPC, statistical process control. Statistical evaluation of output of the process during production is very important. It will tell you the Six Sigma. Quality of conformance, a product or a service conforming to the specification. Which characteristics can be controlled? Only those. Remember, only those characteristics which can be counted or perhaps measured. Main task of quality control is to distinguish random from non-random variability. Control charts, purpose to monitor process outputs to see if it is random. At a time ordered plot, representing a simple statistic defined or obtained from an ongoing process, upper limit and lower limit defines the range of acceptability variances. Now we are looking at control chart. Remember, this is my UCL or this is my LCL. What is UCL? Upper control limit. Or UCL lower control limit. Remember, anything in between this is variances that we go around it. This means the average mean. So abnormal variation when you breach the upper control level or lower control level. This is my control chart that needs to be taken into consideration. So statistical process control will define its measures, compare, evaluate, correct, and monitor results. 6 steps: define, measure, compare, evaluate, correct, and monitor results. Variations and control, random variations, natural variations in output of a process created by countless minors, called common, chance, inherent, are a part of this process. Assignable variables are variation whose sources can be identified, perhaps. Probably you can even pinpoint it, probably you can eliminate it or rectify it. The variability of a sample statistics can be described as a sample distribution. The goal of a sampling is to determine whether non-random, non-assignable, non-correctable sources of variations are present in the output of the process. Control charts. I've just given you an example of a control chart. It's a screen that shows within limit you're working, your performance is up to the mark. A control chart is a time-ordered plot of sample statistic. It is used to distinguish between random variability and non-random variability. Theoretically, any value is possible. As the distribution extends to infinity, 99.7% of all values will be plus minus 3 standard deviation. The basis of control chart is sample distribution, which essentially describes random variability time and again. We're talking about control charts. A sample statistic that falls between UCL and LCL, upper control limit and lower control limit, does not prove randomness, and a value outside suggests it does not prove non-randomness too. So you have this. This is the bell curve, the classic bell curve which we go around it. This is the process that goes around it, beyond which Six Sigmas you are not. This is 3 sigma minus and 3 sigma plus. You will not be. It's not acceptable. But mostly the normal curve, everything comes within normal curve as the quality of production is concerned. And then we have a sample distribution. The sample distribution should also replicate the process distribution to a certain extent. So this is where the mean is all about it. Remember about normal distribution. What is my deviations? The standard deviation that we look into it. See, did I say about Six Sigma this? Did I say plus 3 sigma? Remember, in Six Sigma, this 99.74% is defect free. In 2 sigma, it is 95.44% is defect free. In mean, absolutely what we are looking for it. So this is how concerns is all about it. We need to understand this is the ideal situation. The mean is the ideal situation, and we are talking nothing but distribution, normal distribution for a production process. Allow me to wind up this video with this particular control limit chart. Remember, the UCL and the LCL has to be within the sampling distribution and the process distribution, beyond which you are not, or you should be, you are ignoring it or not considering those products for the final output. So this is what your control limit is all about it. Rather in the cases of input of raw material, rather in cases of output, the quality of material, it has to be adhering to the Six Sigma variation. So there is something called a lower control limit and upper control limit. Within this, products, outputs, inputs are acceptable. Beyond it, probably not. That is what should be noted by the sample, by the process distribution, as the case might be. With this, I come to an end of this video. Thank you for watching the same.